Okay, what's the last piece here?
0.6 entry.
Yeah, now we want to zero out this one, right? Can we use this one anymore? No, we can't use our first pivot because the first pivot was to take linear combinations of the rows under it. We've already zeroed all out. Can you guess what we're going to move on to? Pivot number 2. What's the one requirement for this pivot? Can't be 0, because the whole idea was if this thing was 0, we couldn't divide by it and make them cancel out. So we'll call this thing the second pivot. Yeah, go ahead, Ryan.
So it kind of jumps back to the first board when we were figuring out the first, what do you call it, that one.
The first desired 0 in the strictly lower triangular portion.
That, yeah. For that, why did we choose the C in that place? Because technically, couldn't the C also be in row 3, column 2? And that would be the same thing where instead of combining in A, the top row and the bottom row, you could combine the middle row and the bottom row?
For sure.
Okay, so that's only just preference on
Well, I guess some of this is culture, right? So generally what you'll see is that in using main diagonals is a theme in linear algebra. There's something called pivoting, which is, I want to teach LU factorization with partial pivoting, because that's like the state of the art, so to speak. There's a lot to that. That was, Turing first was thinking about that way back in the 30s, right? So if you look at what they were doing way back when and what we're doing now, there's been 90 years of development of some of the best minds in mathematics working on this. So let's not lie to ourselves and say, like, somehow the introduction of this is where we are today. It's not. But in general, there's this idea that going along the diagonals, if we're going to pivot, we should use those diagonals, because what happens is, if you were to choose that original 1 there, then what would you do? How would you introduce the 0 there, right? Would you use this one, in which case you're not on the main diagonal? Basically what happens is, what's the structure that we want to get to? What's the end structure that we want? Upper triangular, right? So if you want upper triangular and you're going to zero out the strictly lower triangular pieces, start with the one that you want. There's only one in the first column you want non-zero, right?
Yeah.
Yeah, and to be honest with you, there's a lot to be said about this, because when you do partial pivoting strategies for sparse matrices, you actually do this thing where you choose the non-diagonal one because you don't want to move your data around. But formally speaking, in the way that we think about it structurally, when we think about that upper triangular piece, that first one is the one that we want non-zero, so let's start with that. As you get more sophisticated, there are strategies that have to do with both computer arithmetic and memory savings, and bus savings, just moving data around. So there are some things that happen when you're more complex where you'll do exactly as you said, not use the one in the main. Because what do you really care about? What's the whole idea that you're really trying to do?
Just get it to
Get only one non-zero. It doesn't matter the order, but for the formal introduction and as a way to get you kind of accustomed to the way that the field thinks is, we want an upper triangular in the first column. The only one that's non-zero is the top one, so let's use that one as the pivot.
Okay.
Yeah. Later in life, is that going to happen? You get something much more fun, right? And I know what you're going to say. Is it possible to be more fun than this? Yes, it is. Thank you, though. I appreciate that.